talk, 2 weeks, and the through of that. Thank you for that. And today I want to present you some inspiration that I have in the last year with tooling to make orchestration more possible for developers. And my talk today is Helm build fashionable container system with Kubernetes. If you have no fun with container, I cannot understand that. If you don't know containers with this, go to a harbor, look on ships, you see it. Around the globe, you see it. It's a big industry. And it's a nice system for IT, for build systems around the globe. If you have simple systems, okay, you can do whatever you want. You don't have the opportunity to use containers now, also for your building testing systems. If you have the chance to disruptive market, you're very welcome on the stage to tell your stories, and you are very welcome to Helm. Helm is one of the most prominent projects to deliver application stacks on clusters. And it is also built for developers in production systems. And if you have no staging workflow, no automatic workflow, are you very welcome here today to hear my stories about automating the work. To build machines that are more like organisms. And not build static systems. If you have built static systems, you're welcome, but it's not the talk for you. It's a talk for humans that want to build bigger machines, bigger organisms, clever organisms. In my life of IT computing, I built a lot of distributed systems around the globe and learned a lot about static systems. They are bad. They are breaking everything. What we now build with container is to build systems that are more biological and more clever. They have auto updates and so on. Have a system inside it to make clever decisions, to improve it. So that's the mission for Kubernetes, for the cloud native guys. Make platforms for developer, make it easy to do that. And not have the pain on building systems. And they use cloud, industrial style. The garage time has ended. Today I present some inspiration that I learned on the cloud native projects. DICE has started to build a package manager for Kubernetes. Okay, every time we change the IT world, we need a package manager. We have built-in distributed system in Linux around the globe, we build it in Java, we build it in every language that I know. And also for infrastructure style. Now, package management is one of the important things that we need. It is now built in the second generation, and it's preparation time for the third generation of Helm. Helm is one of the CNCF contributed systems now. It's a way that it's a part as Kubernetes started, and now it is a separated project on the integration phase. And Helm is built on the top of Kubernetes and benefits of cluster architectures. It's not built for a system with a single machine. It's built for systems with hundreds, thousands of machines to coordinate our software. It has an abstraction, a chart. A chart is a description of an application stack. And built around images, container images, that you can load from a registry. And you can also build, like the images, to build a container. Now you can build an abstraction description to generate a complete system, or part of the system. It has a classical part of every config management system that I know, templating engine. To make it possible that you can build variants. to have developer environment, to have staging environment, and some differentiation in it. Or you build multi-tenant systems and build around different flavors of your cars or whatever. The metaphor that we now build is like Lego. You have little pieces, then you have a description, and build a car. You can build a house. You can build what you want to build? A ship. A ship. Nice. Nice, a ship. You know the metaphor of ships? You can build bigger ships. And you can build ships for a lot of containers. And the metaphor of the complete container world is to build bigger ships. You all know the nice pictures from ships that have loaded other ships that builds for containers. It's one of the metaphors. And around the globe. And they will build lines of ships. The Maersk line is one of the beautiful inspiration for technology. They start 2010 to build bigger container ships around the world. But they don't build one ship. They build a better ship that ever seen in the market. They build a ship that has the capacity of more than 20,000 containers to load. But they don't build one ship. They build every month a new ship. And then start a line from Shanghai to Europe that you can have a shipping placing time from 1 day. Only 1 day you must wait with your container in Shanghai or in Europe to ship it back to the other side of the world. They build around the ship. Every month, one big ship, and every ship has a cost of $300 million. Can you build it in Europe? No. The only place you can do that is in South Korea. The only place is in South Korea, not here. And that we want also build for IT. We don't want to build one ship, we don't build one container, we want to build lines. We want to communicate in every place of the world with the services. That's the mission. And they don't want to build it for humans. No. 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 We want to leave the planet. You want to build bigger machines that are clever than I, and you, and all. And that's the mission that we want to build. We know this planet dies. 5 million of years, I never know. Next year, Yellowstone can explode and we are not there. We must do it fast. What it means, we must scale. The only chance to scale is not build on premise side. No. You must go to the cloud. That's the only chance to scale. Scale up in the cloud. If you don't believe or trust me, give it a try. And the only chance to do that, do it with a team, with a DevOps team. It's not only engineering now, but it's more inspirational ideas, what you can do the next best job. And build teams from clever peoples to give your best. What are missing in this room? No women are there. That's a problem. You have not the culture to integrate enough of the knowledge of the world in IT. That's a problem. That's the mission of the CNCF, to integrate and build diversity. And diversity not means build diverse systems. That means have contact and go in communication with a lot of people around the globe. And learn from them, from their culture, from their inspirations. What's the next best thing? The next best thing is what we think in Europe. The next big thing, can people that living in, what is the most important, Hawaii, or living in India, or living in Africa, in South Africa, whatever. It can be a clever guy that knows the solution for your problems. And you must integrate them. And then you must build teams and search for them to build better charts, better application stack, better services, and do it with easy peasy. That is what we really want to do. If you don't living in a company that have this mission, leave them. It's the best chance that you ever have. Why I say that? It means for me, the prognosis of the human beings is that we in the next 10 of years, we have 800 million jobs low. We don't have them anymore. We don't need them. But we have a growing number of humans. That can be a real big problem. Normally it's a situation for wars. And the only chance that we have, go in contact and do the best for that. That is the mission for IT, for my mission as person, to do that. And what I learned is I must have better organized systems for that. And that means you need an orchestrator. A dirigent must play music with harmony. You have no other chance to hinder that we not go in war. And Kubernetes is the best abstraction that I know for that. Kubernetes is an orchestrator for a lot of things that you can do. You can change it, you can organize it, you can contribute to the Kubernetes service plugins to make new things possible. And it scales containers. And containers means at that point you can scale ideas.
You make me very curious. Do you have any picture? Where is it?
Yeah, the next slide. And it is in the active open source community on the planet. It's active more than Linux. There's more line of codes, a bigger community. It's a growing community. Last year in Berlin, at the same time, we are 900 people on the KubeCon. At Copenhagen, a half year later, we are 4,000. And on Seattle, we are 7,000. And more people around the globe are interesting. Every company really have a mission, is active in Kubernetes or the CNCF projects. And it's originally developed from Google. That means we learn from Google. Nice. The best thing ever that they open sourced their ideas to the market. And we built the system now, and this means an orchestrator has a control black plane, that is the Kubernetes master, that have some components inside an API server to implement it as a REST API, that you can easily, as a programmer, coordinate the resources. It's a declarative model, it's not a function-based model. That not means you start a container, it means you say, you start containers for me. This is clever. You don't say, start this container, you say, okay, start 10 of this. Or start a group of containers for me. And coordinate the load and make some security systems possible. Network policies or resource restrictions or whatever you need to have policies. It's a real clever model. It comes from KE engines, I think. And it has some components, a control manager, to implement the strategies for your documents that you promote to the API server, and as a scheduler to say, okay, on which node is which of your services welcome. With the next. And if it's die a node, then replace this component to one of the other things. And you can choose from a lot of runtime engine. It's not scheduled only to Docker engines or whatever. It's scheduled, the abstraction is a pod, a group of process containers that are isolated, sharing a network and some volume stuffs and configurations. And it's scheduled to a lot of possibilities. It can be also means that your group of containers are living in an isolated virtual machine. This is not say that the container runtime engine that are placed to your box is needed. You can also start your group of containers directly with the machine with a very lightweight layer and a lot of welcome solution for that. Kata containers or Runway on KVM based or CLI containers or the newest gvisor project from Google. You have a lot of options, and the best thing ever I've seen is you can choose all these technologies and control it from master. In the same time, you can have boxes that visualize things, that working with the old container engines, and then you can schedule your load to this box. And what that means, yeah, you can upgrade. You have no things to change your complete application stacks to the newest version and make it compatible to the complete cluster. If you have thousands of machines, it is not possible at the same time. You have no chance to do that. Or you have enough time, you can wait, Why you wait? You don't do that. And the most thing that I see that is wrong in the complete IT industry is to start a migration project. From one version to another one. It's a big risk and it has a big chance to fail. With Kubernetes, it totally changed the things. You can do that. You can say, okay, I'm working on some nodes with the old one and to schedule my old container to this, and it works. It's good enough for now. Okay, I hire you and change it later. And change you make the storage engine for me, and change a new version and make a new cluster possible that we can schedule faster load. With a newer version, and but all other containers are stable enough, and then we migrate smooth. And that makes it possible. Around the Kubernetes systems, you need infrastructure. You need infrastructure from networking, from storage machines. You need a load balancer or DNS that you promote your services to the world. But it's not included in your Kubernetes cluster, it's outside. You can coordinate it directly with some components inside your Kubernetes cluster. That's the newest vision that Microsoft has. They have now promote for the last months a new one, the connection between their open service broker and Kubernetes, and you can directly inject in your Kubernetes cluster that you need a database or message bus from them. You can directly coordinate it as a native resource in your Kubernetes cluster. Your services outside. And make it possible to control that. You not make a provision mechanism, a new one, to say, okay, new Terraform or Ansible or whatever you need, Puppet or all these other not so nice stuff, to build around your services some provisions that you need before you start your cluster. You can go to the console from Azure, make a managed Kubernetes, contribute some provision things, and it works. 10 minutes later, you have a complete environment, and it's only promoted directly to your Kubernetes cluster. And that makes the picture complete. These little things makes the picture complete. What you can schedule natively to a Kubernetes cluster, so shown that in the middle is the pod, that are your software. And around your software exists a lot of things. You can have a replica set to scale your pods. You can have a deployment to make it possible to change your version of your software and make a smooth transition from your version deployment, your rolling update or replacement update or whatever strategy you want to implement. You can add auto-scaling things. You can say, okay, I have load and all my resources are exhausted, I need more. Or you have a daemon set to place a special component to every box, make monitoring possible, or logging contributions to your analyzing stuff is possible. So you have every time you guarantee that on every node exists the monitoring or logging. You can have limit ranges that not nice guy can exhaust all CPU memory resources, or you can have network policies, or you can promote your services to the external world. Build a service and an ingress that you promote your HTTP services to the world. And this is an abstraction. You can declarative implementation of your system. And what you see is, there are many, many documents. And now Helm come on top. Now you contribute a lot of those documents to your Kubernetes cluster. You have a description, but you must contribute it to your cluster, or clusters. That is a problem. You can declare that, but you must promote it, that you really build an application in the right order. That's a problem. And you must have implement some variations. And the challenge is normally we not solve these problems that I talk about. You change your application architecture. You need microservices. You want build some functionality in the serverless function, or jobs, or batches, or whatever. And in these applications exist a lot of components now to describe them, and each component has a lot of description that it's working. And you must coordinate that. And the problem is hard to manage and edit, update multiple Kubernetes configurations. It's a very hard job. You need very clever people. But the problem is we have no so much clever people. I'm now working more than 25 years in this distribution scene. And now I'm working 5 years in the container space. And I know 5 or 10 guys that are working so long in this container space. And the most of you working for the last month or half year in this space. But before you don't have learning how distributed systems really working well. So most of you don't really know what the kernel do, what hardware do, whatever it is really working. You do something. It's not good enough. The only chance that you now have is learn fast. If you don't learn it fast, I'm fast. Sorry. I can set up your machine very easy with my machines, my algorithms. That's in your words. And deploy all these configurations in a single application, that can be a problem. Share and reuse it. Give it you. It's a problem. To share this knowledge and experience, parameter that, manage the application releases, rollout, rollbacks, and so have some trouble rollback, and so to implement that. Define real life cycles. Validate the releases that are really running. If you have a directive style, that means you say, okay, give it a document. The server said, yes, your document, I think it's good. But the controllers say, I hate that. I cannot do that. And you say, I have to close it. Sorry. That's not true. You have given it a document, a manifest, but it's not working. And every time this thing can break, you must control the state. And you must implement an algorithm to validate, is it really working? It's really working, can I help you? Then you make an upgrade of their components, but the cluster don't know that. And the customer are in trouble. You don't update it. That's a problem. The cluster must know that you build an update and have descriptions in their cluster that you make an update and update all components automatically. And then give not the full load to your component, not trusted very well, don't work. We are giving 1%. 1% is successfully, we give 5%. 5% give 10%. You break, okay, roll it back. And then the cluster must inform you that your implementation is great. That is the new world that we want our builders. What can Helm do for you? What's the part of Helm, a very important part that I want today motivate you to use it is create new charts. Make it easy to build those stacks. Package these charts. Oh, that is a nice idea that's very welcome on the ITO container. That's the best idea from Solomon Hykes. That they ship their container, make it shippable. The isolation of process is one story of container, but the real big use is to make it shareable. And we all know that it's a good idea. Who of you use a smartphone? A lot? Nice thing, yes? But what's the really big idea from Steve Jobs? It's not build these technology cool iPhone. No! Build a store and make it very easy to get new applications, new interesting information. And that is the mission of Helm. Build systems that you can say, I read from that, okay, I use it. Very easy peasy. And that is meaning of make it shareable. Make these concepts, these descriptions shareable. And we all see in the society of the world, sharing things is beautiful. That is what we want. If you make a good idea, I want to use that very quickly. That's good. And if I tell you that it's a good idea, you see me, it's a good idea, make a backup one, please. Optimize that. Please do that. Then share that. Talk about that. Every time you see it. One of you have childs, little childs. What motivates to come to the IT? Use Scratch. Scratch is from the MIT, a very nice and sharing community of ideas for little humans to motivate them learning our program. Play with them. The concept of, the basic concept is the chart. That is the description of the system. If you have played with Lego, if you can build some models without these descriptions, no. You see all these pieces, that are the images, but you cannot build something beautiful. You need a plan. And you right order to do that. And the motivation from Lego is to have ideas, items, very small one, to connect something together in the middle of the very big shiny thing. You worship. I think that is a better idea for me. And you build it on little pieces and build bigger one, and then you have a large one. And sometimes some Lego engineers say, I have found a missing piece. We must create it. That's our creators. And that is what we want to share in the near future for IT. To make these releases possible. One incarnation of this model. You can vary it. You can say, okay, it is in blue. I buy red ones. What you can do. You build on repositories. That are these stores of Lego that we build now in IT. And they have a nice name. This component has a nice name. It's a chart museum. Go to this museum, look around, and see these beautiful pictures. And get it, and go to your home and say, now it's mine. That is the idea of charting of Helm, really. And you can do that, these variations of this model, of these beautiful pictures that you like, and say, okay, colorize it with a new one. That is templating. If you build houses, you all know that you want to build your individual house. And templating is the chart to do that. How it really technically works. It's very easy. You have these clients, these Helm clients. There's have a directory of these description of all these manifest files, these parts, these services, these ingress controllers, set network policies, whatever you need on your components. Contribute it in the right place after templating to the API server, and then it runs on your Kubernetes cluster. It needs some components currently with the Helm 2, the Tiller components, place it in your cluster. That's the coordinator to store in the API server on config maps the release, what you are building now. In the next generation in Helm 3, you can working only directly with the API server and contribute custom resource documents. But you must know that's an evolution. Guys start this mission at year 2015. In 2015, the Kubernetes cluster project was interesting, but it has a lot of missing features. Now, we are 3 years, 4 years investing in this Kubernetes orchestration system. Now we have more solutions for that, and the Kubernetes community makes a decision to use them and make it better. Help. That is the mission of open source. Make it better. Learn what you see. Reflect that. Give feedback to yourself and say, okay, I have to do that. Now I learn, I can do it better. And don't say, it's work. No, do it. What does it mean currently? You must contribute a special account for that. Normally, don't start a Kubernetes cluster without airbag. That's not a good idea. Without security, start something is no good idea in these unsecure world. You need a special account and then bind a rule to that. In this very little example, you give the tiller the trust that you can contribute more. It's not the best idea, but the first view on that is this implementation. And then you can use these Helm client for contribute to releases. You can, the first thing is best, you can get some completions in your shell and bash in that shell that you're doing at the first. Or you have too much time, or you are typing better than I. But I need that. And then you can create a new chart and directory for an example to implement a simple microservice as a template that you can contribute. Don't delete it directly. The first time you can install these things after you insert in a file your application container. Helm is not building for containers. You need another tool. Docker Engine, build.rl, Canico, Jib, or whatever container builder you like. And you must have good software for that. Kubernetes is not built for debugging. It's not so nice to do that. It is a building for orchestrate systems that are hard enough to do that. If you build a container with shit, you ship shit. The container don't make your software better. It's your software, it's your mission to make it good. The container make it easier to ship it. But shit, more shit. It's not a good idea, I think. What our Helm do now is you have an application like Tomcat, have your application inside Tomcat, use a little cache in Redis and store your very important things in a relational database in Postgres. And the client, get it from a GitHub repository and push it to your server. You can do it with one line. It's complete stack. And not only the pods, the complete stack, the description of your policies, your communication links, your resources, whatever it is. Your secrets to use the Redis and Postgres, and all that. You can automatically deploy it with one line. That the usage of deploy something, part of that, is easy. Easy peasy like start a container. Now you start big systems. That's the next evaluation step that we really need. And then you can promote it to Git and make automating that with GitLab or Drone.io or TeamCity, Jenkins. I don't like this word, but okay. If you have traditions, use them. But sometimes traditions fail. Simple config map, static one, you can create a chart, removes all the templates. I don't want use that microservice. I will only distribute my config map with hello world, then I install it, make a dry run, see that the template etching really work at the first time, then you install it in a release name in a namespace, in a separate isolation namespace, and then you can get the manifest or you delete it. That's the complete state, the flow that you need. You build it, you ship it, you run it, you remove it. It's okay. Between remove it, I hope you give it a chance to get it better and update it. Okay. What you can really learn, oh, sorry. If you want to reuse something, complicated one, you install Prometheus or you install Grafana, you can do it. You make the repositories, the shard using available to your local environment, update that, then you can install it, use some parameter, airbox that you use, persistence volumes not, you have local ones, and then variate your deployment, and then install Grafana with 2 lines. And if you're looking in the charts, you see the complexity to deploy software. Software deployment is not easy. It's complicated. And you can read wiki, search on the internet to do it right. Now we have a place for this knowledge. Make it available in your charts, make a good description to that, contribute it to the world, and see it really works. Yeah, you can install your Ingress load balancer like Traffic to install it. After that, I use kubectl to install my image, who am I, and contribute as the ingress to the traffic. Very easy. That's the tryout that I need to build the right chart. Before you build charts, you must give it a chance to try it out by yourself. If you can do it by yourself, your often sucks. I'm very sure about that. But these documents you see, that's a very small one, very simple. But after that, you can directly use it. It's a combination of Helm, that's easy, and you see the differences? If you package it as a shard, it was easy. Then it's a clever idea, you see it. Before I have Prometheus and Grafana, how can I combine it to a complete system? Can I do it with a one-liner? Can I combine chart of charts? Yes, you can do that. What chart directory is, it has a description. You can add a license or README file. Then you have a sub-chart directory. Then you can place your external charts as tarboards or directories to make good components with a lot of parts. Then you can have a requirement YAML for external Prometheus traffic or whatever you need. And then you have your local templating engine to contribute it. And you have a values detail to make all these variables options whatever you like. That's a very simple directory structure. These complex systems. But now you have a very good abstraction to split your application in smaller pieces. Before, we built monoliths. We can control it with your EDA or whatever you need, but it's not the best idea, I think. These objects not really finish. Every time you have an incarnation of that, you give it a new chance to fail. It's not a device.
What's your take on the quality of external charts? So it's easy to just install
Current
an
state?
external chart?
Current state, we have these from the Google people's maintained Kubernetes museum that have a good quality. You see it, contributions are going every day.
To the whole repository.
To the whole repository. And to a lot of parts of the whole repository. I think it's 200 or so components now, charts available. 50 extensions, 80 applications, and so are well packaged. Most databases are packaged, or you can find it on the map. But the quality is not guaranteed currently. We're working, the complete world working on this topic. Make it possible to all these variants. It's not so easy. You can see it in all configuration management systems. That needs time. You can see it in Ansible, you can see it in Puppet, you can see it in Chef. To get real good abstractions, that needs time. And we are on the beginning. That's the phase. It's not stable. Pure want. The biggest problems is not the charts. The biggest problems are the images. And you cannot trust every chart that these images are very welcome on your systems. That's a problem. They are not have a signature, not coming from trusted people that you can really have a contract with them, and so on. That's a problem. Yeah. The chart description is like manifest in Java or other packaging systems that you say, okay, I'm the author from that. There is the versions of the chart and the versions of the API of the charts. You can find the sources that are the maintainers of the projects, and then you can read, trust these people or not. And if you add a license, I think it's a trustable, good idea to do that. But you must analyze that parts that you integrate in your charts are compatible with your license. If you add some GPL stuff in that, that can be a problem for your application. And if you are successful, then you got some posts and that are not welcome. What the values file is a simple YAML file to have hierarchical values that you can vary some parameters. Here you can enable persistence for that, or use the passwords that are generated, or use a special image credentials that you can download your images from a trusted registry. Or you can say which English controller you enabled for your English document to add some annotations for special needs in these controllers. To have a variation that some of your tenants use traffic, other people use Nginx, and so that you can vary it. It's a complex work. And you can add some dependencies to make it possible for Postgres and Redis to get your application working. And this, all these subshards have a version, and then you have stabilized your contribution to your systems. Do not follow the latest. That's an anti-plat. Follows the latest is anti-plat.
You mentioned passwords. How are they protected?
They are not protected. If you protect them, then you add it in your pipelining system and get it from a Valve or Trezor.
So real passwords should not be
It
inside
is
the-
directly decorated. You must generate it if you really need more special trust.
How you get them inside? So what is the...
It's my pipeline. It's no problem.
No, I mean the kind of transport from somewhere in the pipeline into Helm. Where do you put them in?
I put it in a pipeline. I trust my pipelining system. It's containers, and I
That's
trust
fine,
them.
But
my
how
platform.
do you give them to Helm?
It's no problem. It's no problem in my. I inject it as a command line. I can override the values file
Okay,
on the
so
command line, the
When you
parameter.
call Helm.
Yes, and I call it before, get it from the Valve in the
Or
normal way, and then inject it in the pipeline And it's a one password. I have trust my CI, inject a master password, these master passwords, open a one-time password for this process. It's no problem. You cannot do it by hand. That's a problem. If you do it manually, it's a problem. If you do it with a machine, it's no problem.
But like in Jenkins, you can still see the logs. If you pass it through a terminal, like is there no mechanism to get it, like in Terraform you can get it from all?
It's no problem. It's no problem. It's a one-time password. You can see it, you can steal it, you can promote it to the internet. It don't care me. If you have a password, one password, then you must have a clever mechanism to trust your logs. Don't promote it to the internet. Trust is every time a problem, but you must trust something, and then do your best. To don't lose the key. Don't promote them. Don't clone them.
I didn't get how this one-time password works. So
You can call it to Wolf from Terraform, from HashiCorp. It's a product. So you can have a master password, call that, you get a one-time password, and then it opens you the trust to some keywords that you generate. If you go to this API, you get a new password, and then you get it. It's no problem, read it. It's not the topic of this talk. It's another thing.
I've understood that the chart references to a package of manifests.
Yeah, of other charts.
It is done by repository? Or?
Yeah, it's a museum. But that's the link directly to the Kubernetes chart museum. And you can have multiple Postgres and build an alias from them that you can have used for some parts of your things, different versions of the same product. That some parts of your engine use Postgres, whatever is the new shiny one is, and some other parts use an older one. That's no problem. In the Helm 2, you have no clever dialect to don't repeat yourself. It's a nice thing. It's not so a good idea. We currently use these helper files to define some functions that we can combine some value parameters to something better, and have some pipelining system from Go here to trim it and trunk it, and so or use the Docker keyword for your image password to combine that to a bigger document that you can contribute it in every place that you need an image pool secret. That's not so easy to do that. And it's not a nice dialect, right? That we changed, I think, in Helm 3 is Lua. We add to Helm Lua script, and then we can override functions. So then you can say, okay, at every time I want name something, I then compare it with the chart name and values override. You can do another function and override that for the complete charts if you use the same name in all your charts. That needs conventions.
Which is hard for external charts.
Yes, that can be a hard problem. To override something or make your convention possible in the complete subcharting world. Yeah, and then you have your templating style. You have flow control, if then else. You can have with some data in that. You can have ranges. You can iterate some values to create bigger combinations. You have data that you can explore in some places. You can have variables to set up. You can have nested templates to make your life a little bit easier or complex. This writers only pattern, is it right? It's not for readers. It's a writers only pattern to do those stuffs. The writer say it's easier for him, and all other people say, you are stupid. I don't understand your abstraction world. Be careful with those mechanisms. check it before you are happy about your motivation to make your world, your writer's world easier. The first thing, if you have this emotion, go to him and say, you understand that? If you said no, it's not the best idea. If you must train people, it can be the first step on the wrong direction.
What about Helm 3 and new scripting?
With Lua, it's more complex than this. What you can also nested some files in that. You can have or store some of your data in files and processing them. All these nice templating world, all what we makes the life complicate. You can do. You can the documentation of the Helm project is very, very good, and I like these tips parts. Hottest tips on the world that ever people must know. One of these tips is to implement those credentials, something, silly things, to pull, make a document and pull it in the secret document from Kubernetes. And you see that, wrote it one time, and please forget it. Hope it works. Or if you have some dependencies, that you have problems between documents and you change one document, but you need a re-promotion of another document, that can be a problem, but this very tiny example solves these problems. You will build a hash key of your other file, included in annotation of another file, and every time your file changes, the other file also changed, and communities say, it changed, I promote that. That's good. Sounds good for you? Nice. You clapped your hand, that's great. But complexity in the provision world is ordering dependencies between components, and Helm has a very nice idea to promote these features to the packaging manager, to have clear, you can pre-install, upgrade, you can plug in your documents in these phases, and then Helm pre-install these documents, and then you can define your order on the right moment. And the best thing ever I've seen is not only install it, you can also have some hooks to delete it. That's really cool. If you want to store some data in your clusters, you two guys do it. You promote it and you want to delete it. And you say, okay, I have data in that. I hope you have implemented some documents to back up all the things before your components are deleted, if your volume's gone, your data is gone, and then you can motivate your customers to type it again. And it's very easy in the Kubernetes cluster to make this nice story possible. You can shock your colleagues with that. I hope you have make only a joke. And after that I tell them I have a backup. But this moment in time, this motivation of this guy is very nice. The complete flow is defined, the chart is verified, and then install all the pre-install are waiting that are really ready, and then promote your major charts in the right way, then your post-installs, and then wait. And after the complete release is okay, your client exits. That you can have. You can wait. In the kubectl, you can't wait. You can promote the create, but you can't wait. The promotions are working very well. With Helm, you have a controlling component that can wait for you and make a clear signal to your process that's now working. First time. It can, in the next moment, it can break totally. And you must do a lot for that is really stable enough to make the next possible step. And then you can deploy those nice architectures. That's a very simple architecture for microservice and Kubernetes. You have a load balancer to have an outside traffic, have an ingress proxy with HTTP that watch on ingress document. That ingress document has the service, and the service has the pod, and you have some control elements to scale that and deploy a new version on that. That's the normal architecture on Kubernetes to build those systems and build a lot of them and change it very fast. And Kubernetes help you to do that. You see, that what you do as developer is add some pieces in the containers. And you see that if you're looking really, here is something wrong, missing an eye. Please promote the next better one, Peter. And if you have so simple applications that it's a motivation for ever engineering, do complex things. If it's not easy enough for you, make an architecture that's really complex, that nobody understands that, and Kubernetes can help you to go this way. And I use for this way to make it possible more complex, use this very prominent voting application to vote cats and dogs. It's a very simple one, but I have found a very, very complex implementation for that. Why? I think voting for cat and dogs have millions of customers. So I think I split my application to vote for cats or dogs and split the result to look the vote on another service, implement for faster tracks on vote, do it in Redis, and have a promoter job to the resulting pod. And split all these three pieces from the applications in separate services. And I think I get more votes for that. And that means I must scale my Redis server to master slave to make it robust for the traffic. The complexity in this architecture not come from the problem. The problem is very, very easy. But if you have really big traffic, an easy function can be need a very complex solution in system architecture. The problem is not build the functionality. No. To have a system around the globe that can scale and make it right enough. The Twitter stream, the cats are in front. No, all dogs, come on! And motivate a lot of people in 1 second to get a real big traffic. So simple problems exist around the globe. And what I do is, these applications don't come from me. It is a very old Docker-style training applications, this idea, to make the Docker Swarm product and show the possibilities that you can use that, and I reuse that now. And make it more scalable, more traffic fine. And do it with a simple chart. I add these Postgres Redis things from the chart libraries externally and split my application pieces in result, vote, and workers, and have a ingress promotion to the complete system. Yeah, and I'm a big fan of demos, but And so most times, these demos are fake. Sorry. I have no video from that. My colleague Niklas makes this demo possible 1 hour or so, 4 hours before this presentation. And I'm very proud to present that. Cats and dogs. What you can do, these nice prototypes. I vote for dogs. Now I vote for cats. That's a simple one. It's a nice one. Every time I push an ad, I can go to that. And then can I go to the result page, and I hope I see these results. Back. Yeah. Move for dogs, move for cats. Okay. We need another browser. Another voter for that application. Good. Nice. What we do to make this demo possible. You see, very simple application. Every people of you can do that. I hope. We build a very complex application stacks. We have a lot of developers included in this project. Sorry, we have not enough time to choose and train all in the same language. What we really do is I hope I can show you that. What we are set up. It's a GitLab to automate all this stuff. We automate all. That means we have pipelines to set up the system, provision that at Azure, set up GitLab, a separate server to the job, and do all this in pipelines. What the strategy on the B42 is, add to the project a tag, and that is enough. If you build a branch, you create a new one. It's very easy. That is the strategy that we want to use. Sometimes it means if it is a tag, you need some things in your vault, and so set up it before, that you have all credentials inside it, and so that is the vision that we have. To make it very, very easy for developers to build a new tiny variation of the product. And set up automatically. And if you merge the branch, see, your contributions are very welcome. That's so nice. You show the cat as a pictures. Nice! I won't have that. And after delete that branch, then the complete system that you try out is leaving the planet. And see automatic pipelining systems that we built inside the B42 to have that. And Niklas is a nice guy. You see these fixing guides from tomorrow, from the morning, and they need a lot of steps to get it working. And 42 is the solution. Yeah, nice. That's the best thing ever. That's the answer of everything, of the life. And Niklas do that without coordinates that. I see that. It's the before this presentation. It's What a beautiful thing. Or you have motivate them, make a failure. What you want to get it from me? I don't know that. That makes me very happy. What is the project? What we do, what you can see in the project, in the details. You see a lot of source codes. You see these. Yeah. In a minute. You see, we tried out for this demo. It's not a nice, not enough time to do it very, very well. We see conventions that we have, but it shows enough. What we have, the first stage is to build all these images. We have some project folder in the projects to build all these sub-images that you can try out as developer every image for yourself to make it possible, working together. And then we push all these images to registry, the GitLab registry, the product have a registry. The nice thing on these GitLab thing is you can do it with parameters, and then you can have your own GitLab. It is a failure if you have a centralized company management for workflows. It's a failure, totally. It fails every time. It's too much dependencies. You need a GitLab for every project, for every team. Not for the whole company with 10,000 people or whatever I see. It's a failure, totally. You can look inside, if you don't trust me, look on every tech radar. It's one of the anti-patterns. If you use Jenkins without containers, you have a very, very big chance to fail. You cannot have a project that use this plugin or this plugin. So on the GitLab side, Drone.io, Circle.io, we start containers. And then you can vary it in every job step, your version of your tooling. And that makes your complete contribution stable. Did you have an innovation in one job? It's not anymore needed that this new shiny thing is needed for everything. Please redesign your Jenkins and do it only with container, or drop it. Drop it to a right container CI, like Drone.io, like GitLab, like Circle CI, or whatever it is. Integrate the container stuff in your build processes that makes it faster. Faster and faster and faster. You can see how I integrate this Kubernetes stuff in my pipeline. You can doing more clever in GitLab, but this style I like. I have contribute a container with Helm and Gitlab tool inside it, use it in this step, have a before script. I need the credential for my custom. I contributed it as a base 64 string, and then promoted to the config that the Helm can find the credentials. In it is a client only. I don't want install the tiller. Then I resolve the dependencies, these Postgres and Redis stuff, and then issue it, and then upgrade it. And it can green again, every change you can do.
Is this Helm deploy and Kubernetes deploy provided directly by GitLab? Is it plugin?
No.
Plugin.
No, it's built by B42.
Okay.
We built all tools that we needed for GitLab on all these steps. It's not open. But you can find some Helm kubectl in the open source world. We are not making the decision that we open the blueprint that we have. It's no decision. Now we trusted it out with a lot of customers. It's a working process. Before we make it open, we must sure that it really works. That is the tiny description that you see that promotes the project. It's a build step and a deployment step. If you can looking we draw some examples on that, and now we have this routing reference thing, and you can see the charts in there. And in every of these projects are these tiny components, and the vote part is that. If you want to see what I want to see, the implementation, the road implementation. It's a Python one. And what's the major lesson that I learned on all these different stacks? The worker is written in Java. Nice one. I'm a Tomcat committer and Apache member. I can implement something in Java for the last more than, I started with Java in 95 or so, and now tried out for more than 20 years. I trust them that you can really do it, but the result part is written in Node.js. What I learned, in the HTTP world, you can map something, right? You can do it with domain names, or you can do it with passes, or you can use some headers to shape your traffic on something. But the shitty Python and Node.js in the application stacks, it's not easy to set a context pause to your applications. Or set it by a variable. That's not nice. You need a templating engine for that, and replace it on every places before you can give it to your compilers. That makes these examples some exciting journey for us to try it out, to have in the same namespace different releases on feature branches, to have complete stack for a feature branch for you, then you can contribute, delete it, you have some multi-tenants with that, and have tried out for a lot of developers and motivated to make a better cats and voting dog application. But it's not so easy to try it out in this complicated technical world. I'm Tomcat committer in Java. All stacks can do it for you. That's so easy. But on the other worlds, I know a lot of friends, ask them that, why you want to do that? They only have this choice to change the domain server for that. And that means you must control your DNS server for every release you want. Oh. In some organization, the DNS server is not so flexible and dynamic, or you as developer can control them. You have not the trust on that. That can be a problem for your workflow, for your innovation. That's the lessons that these simple examples train me. It's not smiling lesson. The part of Helm, the deployment is easy. If you want to see more of these exciting things, ask me after the show. Here you see these applications. We are automatically generate by provisioning a domain name to trust our domain. We have used Cloudflare. It's a very dynamic API-driven DNS server. That's easy for us to do that. And you see these nice examples that 42 is the solution for these simple applications to see it are complete and robust. It's a simple one, but the complex use case is not the application. It comes from the user standpoint. My stakeholders say, we can have millions of users. And if you see, oh, Peter, that cannot be. You have, say, you use smartphones. You say you are working in the IoT industry. It's this very simple streams and informations, but it scales. It must scale for millions of messages per second. And you must robust systems to do that. Complex is easy. What is the Kubernetes stack? What I say. It's my blueprint. And I learned As a simple one, you have volumes in network. It can be a problem. Ask Alexander of that. If you want to manage storage, that can be a hard problem. And a lot of guys of the planet searching for that, for the solution. The golden eye is not found. You need hardware. We discussed before, Alexander and I, hardware can be a big problem in the volume storage place. If you choose the wrong one, then you have no performance. You have choose the right Linux OS, the best kernel that you can ever find. One of the extensions that we every time inject in the modern kernels is WireGuard, to build a trusted network between untrusted cloud providers. Everyone from us must know, if you choose a virtual private network on a cloud provider, it's not crypted. It's isolated by access. The provider can touch it and see all the data. And some are one in another box, finds that the provider scheduled a machine with hyper-threading is on. They can touch it. That's not nice. We don't trust them. And the best idea you can have, build your own private network on WireGate base. If you want to see aggressors, go to Hetzner. If you schedule your Kubernetes cluster untrusted, it needs 5 minutes, you have a guest. And then you can learn how you can find some mechanism to have a secure Kubernetes. Kubernetes node needs some container runtime, networking interface, storage interfaces, and logging interfaces, and then you can add your own components for logging, for metrics, for tracing, for monitoring, for your security. You need special policies for that. And that's the add-on on extensions, and then you must control your outside services, your databases, your message buses, whatever you need, your applications, you must touch against that. And you need pipelining to automate, to promote all these artifacts to your cluster. And then your application can come. But these topics, you must build by your own. Or find some clever guys that do that before. And I know that not a lot of clever guys know that. I'm not clever enough for that. That's very, really true. I'm learning a lot of these stuff, and we are putting a lot of knowledge from friends together, and I hope we can make it in some months really, really good. What we must learn is to control and extend the Kubernetes server for do that job, and to find more people that are interested in these jobs. You can find a lot of guys who want to build a new JavaScript framework and this CC stuff, but the really interesting IT you can find nobody. Okay. If some of you want a job, it's nice to ask me for that. What you really must do on Helm stuff, you must control your security. And what we learn is don't deploy the tiller to control the complete cluster. Let the tiller control a namespace. And every namespace a new tiller. That is the decisions to start the Helm 3 project, that you have the normal security that you can define with the API server as extension, and not controls with the tiller. That is the new design of Helm 3. Then you don't need in this tiller part again. But what you really need is that you must trust an administrator rule to generate the trust things to your applications before you, funny guys, deploys those applications that the voting say. That these voting applications don't have the rights to control the API server. It's normal in the pod to inject every component, the API key, the master key, that you can do everything. That's not a good idea in production. You control that nobody from the other namespaces can go directly to your cluster components, only from the outside. You control the access from your monitoring components and all these stuffs, but that's a job for the operator with this administration security room. And you have a little trust to deploy your component. And normally, your guys, your humans, have no chance to change the cluster. Your only chance is to checking something, and the pipeline has the right to change the cluster. No human, no developer has the direct chance to change the cluster. And the network policy default is deny all. You must ask the operator for communication. That's the only guy that has the trust that say, you two guys, yeah, you can communicate here, but nobody others can communicate directly to you.
How do you handle network policies with foreign charts or charts from the internet? That you can
must learn
without looking.
Deny
you
all.
need to, you do deny all and nothing works, and then you have to look into how these labels for each and every component will be generated to set the network policies.
You can identify a good chart if the network policy is included. If you find a chart that have no network policy, what's the guy want to do with you?
The traffic chart doesn't have some.
Yeah, a lot of charts don't have that. That's what I'm talking about, that I say, okay, we're on the beginning stage. I hope we can make it better in the future and have clever conventions to say deny policy all. It's not a developer-friendly convention, but it is needed. A lot of my customers do this deny all policy now for developers. That at the first stage, the developer may communicate which communications the system that they are designed have. If they can't communicate that, go away.
Isn't that against the idea of DevOps? I mean, if you have a separate ops.
Yeah, it can be in the team. It can be in your team. But
probably must be.
Don't trust every people. No.
The one that defines the access is the one that writes the
Yeah,
charts?
you can communicate it clearly with documents. What we do is you have the right to make a pull request to the operator guys, and then make a review and contribute to that. You can have this knowledge. You can define these policies, no problem. But it's a 4I review need to trust you. You do it right. And if the operator changes that, then they have a pull request to you to integrate the change to make a review again. That you can. That'd be cool. It's not the policy you can't do that. If you say, okay, well, I want to try it out, use your notebook. Use your implementation in the cluster for that. Make this setup possible, whatever you need, but don't use the developer system for that.
But isn't the namespace
Namespace is not
nice
enough.
boundary
No.
for that?
That have no rights. It's only naming. It says no isolations or whatever. It's only an isolation for names. It's not an isolation for network policies or whatever. No. You can build it with this pattern. And you have an operator to install all your rules in there. You can automate all these things. There's no problem. A lot of projects in the open source area now promote their features to make it easier to set up those things. Yeah, pod security policies, you must set up that. Don't trust everything. make it possible to say, privileged container, you can't use. Sorry. Promote to host network or host pets, so say, no. Run it as a user, yes. Don't run it as root. No component of you can run everything in root. Rootless containers are welcome. User as a Linux, run as any, oh, not nice. Must run as is a good policy, run as a special users. You can change it in a range of some user IDs and something tried out. Deny whatever you can. That make your system secure. That I learn in this way. Every time I discuss it with some expert of this scene, they say, push the cable outside of your computer, that's secure. And that's the default policy. If you push it again, have a rights possibility that not everything is possible. Before you go to the network, review it with different peoples, with different knowledge, to find all these things.
So what you're saying is that I, as a developer, cannot experiment on my feature branch or something.
On your cluster, you can do that.
No, I have my developer cluster for like
developer clusters are productive.
Isn't staging for stuff like that to ensure quality and to promote production afterwards? Well, that's how wouldn't that be for production, for staging? But if I'm a developer, have to wait for the DevOps clearance for my little feature to push. So it's like ops. Is that what you're saying, or?
Yeah, if you really want a secure system, you must respect the rules from the ops.
Well, that's the staging and production system for me. Well, if I want to experiment
if you
with
need
some
so much
access patterns, some messaging patterns, some routing rules, some I don't know, load balancing stuff, I don't have to wait for some guide which may be in the
you cannot wait. You cannot wait 30 seconds.
Policy.
You can wait 30 seconds.
Mm-hmm.
Yeah, it's okay. Then we can do that. If your administrator is a machine, they can promote your pull requests, and if it have some conventions in that, I test it as an administrator, then I can make it automatically and say, okay, it works for you.
So you're my dependency.
That's the new style. The site reliable engineers automating all these stuffs. It's the first time it's a person to review that. If this person have a lot of jobs, what they do? Make it faster? No. Build a machine for that. And if you're in the right group and have enough trust, then the automate contribute your contributions directly.
So if
a new body comes to your teams, they have no trust. Every time I need a review. That's the policy.
But isn't the real point where you need that thing secure?
Build secure systems.
No. What I mean is, you need it secure when you're doing the release. Before there is a release, there's no need for making it always secure.
Yeah.
Because you're making it slow.
Choose it. If you really want to have a secure system, do it right at the first time. Every release, every change, you think about this topic before you do that. And it can be that at the first time you are not have enough knowledge to do it right. But that is the change what I want to promote you. If you have the trust from the operator team that you respect the rules, then I get you to the list. You can do it automatically. If a new body comes and makes some fidgets, we have a policy to help them, to train them, to see, to review them, and help them. Not say, don't accept that. Discuss it. Then these people need my knowledge. And the automate sent me a Slack message that something checks in that need my motivation, and I do it very, very quick.
Just to make sure, are you talking about the production server? Or are we talking about the
For me,
developer-specific server
for
which
me,
is used to
the
test
important system, the important systems is the development space.
So if I want to try, for example, like Kafka or like Rabbit
You can
and
do that.
Redis and stuff, and everything is protected with policies, and I can't talk with this port or that port or this service. So every push for me, like every 5 minutes, I have to wait another 15 for the acceptance of the.
Sometimes it
Measure
is for new components, that is possible. For trusted components, it goes very
So
quick.
that's your advice.
Yes,
Okay.
let's see wise. But the first time, I need sometimes that you have respect the secure system. That is what we trained and what we want trained to build a real secure system and build with nice organizations and learn from that to do it with speed.
So what was the impact on your productivity with this style?
We are very fast with it. We automatic all these stuffs.
And so like push to production is like what?
It depends how much stages exist and how long the test case is needed to validate that. And with very small implementations, you wait 10 minutes
10
to go in
minutes.
productions if you have good test integration.
So basically, security is just another test case.
Yes. Yeah. But you must highly motivate a lot of developers to respect the rules.
And how often do you release to production?
On some customers, every change after 10 minutes go in production. And some customers need releases every week, but have a lot of integrations, hundreds of stuff. You see these morning thing from Nicholas? We have needs for getting the demo working with all these setups and so on. 42 steps. And 40 top steps are build jobs to build and release.
And we have like custom tooling for validating external charts. That's jobs.
No,
No.
we are not,
You do it
currently not,
manually.
we have that. We make, before we use that, we make a review and then go ahead.
So that you decide on case by case basis.
Yeah.
Okay.
It depends maybe on your process, how secure must be your system. If at the first time, a lot of projects need a fast development speed, and then we lower the barriers, and in the process, is the product become important enough, then we add trust in the security things and train people.
What did you just mean by lower the barriers?
We say, okay, we have no security. Namespace open, do your job.
Okay, so it's like, okay. So
Try it out.
Okay.
Try it out. But in the most cases, we set up for those systems a playground, not the normal developer staging system. And after these projects have enough trust, we integrate it in the more secure environment.
So it's like basically a playground.
Yeah, it's a playground for people that have an idea. Then you must lower the barriers. But you must add to the team a DevOps that all have this mindset inside it and watching around, train the people and do the right stuff, wrote the hand charts, review them and make the playground as a candidate for the development. And don't stop the innovation from people. That's not what I want to say.
Maybe a question. So how big is your team, or how many teams do you have who work like this?
We are, personally, the B42 are very small. We have five guys. But we train organizations that have 10 teams or 3 teams with team sizes from 5 to 12.
And they follow this model?
Yes. The biggest customer currently integrate 100 new containers per month. New not upgrades, new projects. They are in a transition phase of the complete organization. And migrate products to the development environment.
Probably just one last question. How do you structure larger organizations with when you deploy with Helm? So you can integrate a nest, but this is probably not what you want because you want to have some isolated apps. And what's your take on that? What's the size of one Helm deployment?
I don't make it big. Split your application in small parts that are integrated domain for that, and make the integration about the ingresses, and that make it possible to scale your organization and teams to work in a bigger application. But split these things. What you can learn from Zalando as a use case is they have a lot of teams. They have more than 2,000 developers in 7 places in Europe. And what their story is to have clusters for every development teams that they are really operated by themselves, team size. And give them the trust to do that and the help to do it right. And there's another organization style to not have one big cluster, have a lot of them. I think there are hundreds of Kubernetes clusters supported in AWS with different sizes. The half of them are in production, the other half is development. They don't have the development and productions in the same cluster. They split them. And they have generators for clusters that a new team in some minutes or so can generate, spin new one, a playground for an experiment or whatever.
Is there any possibility to use Helm charts with Kubernetes Federation?
I think so. The only limitations is the manifest that you can use in federations that I typed out. It is a directly communication with the API cluster. You communicate the same dialect. If your federation things have this API, it works. What lessons I learned? Use the immutable deployment pattern. Replace it, don't patch. It's a Phoenix. See? Don't patch anything. Replace it. Let it die. That's a normal thing. We are living on this planet, and normally organisms die. Some organisms die in seconds, others living for hundreds of years. Only system pods needs access to the API server. Don't trust everybody. Add pod security policies and limits to resource usage if you don't want that your cluster crashes. Limit network access. Add these start with deny policy to your organization. Limit with airbag. Check container images with infections, viruses, whatever it is. Add know-how to your team. That is the best thing that you can do. Let people learn. Share your knowledge. Think about chaos engineering. Read it. We are living in a chaotic world. Automate all. Don't allow manual manipulation of your Kubernetes cluster. Don't allow people to do that. And then you can have a container, good, well-designed systems. And you need supply chains for your containers. That is the abstraction that we use. You have your team, your source code management system, your CI engine that generate jobs, that has a runner on a lot of systems, have some parts to build your stuffs, and then you deploy it to your cluster. It's easy. You must generate your artifact, use them. And the biggest message is now you can do it for your system parts, not only for your images. And it depends how big your systems are and how you can control it, how you change it. If you change it very fast in a lot of parts, make it small. If you change it on a longer release cycle, you can use bigger components. Yeah, what we do, we love automation. We like it so much, it is so helpful for us. We use containerization in every place. Things that can be used in container, we don't use it. And we have impact to the organization. You must motivate all people to go on track so fast, to change everything, to improve everything, to communication about new improvements are welcome. You can make phases, and people trust you to make it better. We have an architecture for these cloud-native systems. We train people, we consult, and we integrate all this knowledge in the blueprint that we have internally to describe it, what improvements works, and what story is a failure. Yeah, I mean, that's the word from Steve Jobs. Stay hungry, stay foolish. If you have no crazy ideas, you can't create improvements. And use a lot of technologies to use it. That's some of the technologies that we use. And use nice logos for your projects to motivate women and other peoples to come to you and share the knowledge with you. Write comics or whatever, you motivate people to have foolish ideas. We're hiring people that have foolish ideas and gave those people the trust to try it out. Yeah, what we do, trainings, commercial side, we train people that we have enough money for these foolish ideas. Do that, like Adrena and the last days do that. Currently we prepare container basics, a lot of Kubernetes stuffs and GitLab, and with Alexander we now try out a storage WOOC day that motivate people to trust Kubernetes to store data inside it, and motivate them to do that, and try it out, and help it become stabler, more stable. Yeah, and what I, in the last half year, do is to add all my creative ideas to a poster. And if you like this talk and want to see a lot of diagrams that are really helpful, I think, in the Kubernetes space, then go to this registration link and help us with money to make more creative ideas and spend it to the community back. Yeah. And now we are on the last slides today, and come to the topics. It's really nice. Drink more, eat more, discuss more, whatever more. Don't go outside, it's raining. Yeah, you can share more ideas and find communities. You are welcome to come to the DevOps Gathering in March next year to share your ideas with the Docker. That is the logo from the DevOps Gathering conference. It's the dog. You see, we are vote for dogs. And yeah, you're welcome on the party, on the nice campus from GData. GData is a security company. We in Bochum like security. The complete city, the governors in that support us. to build better secure systems. We have a university with a lot of professors and colleagues to build a secure world. And that's a mission on the IT book. Yeah, and if you want to read books, you can read the German Kubernetes book, or you can read the nice one, Kubernetes in Action. Read this book, release it, really. If you don't like trouble, read it, or continuous delivery. Read the handbook of DevOps, or Lean Startup if you have really foolish ideas, and have a nice track to hire, spend it to the markets, then read this book. And there are really foolish ideas in this book. But they need you to try it out. Now is the time to ask me anything. Whatever you want, do it.
So, thanks, Peter.
Yeah, and now I have spent honey from the Rue Valley for every exciting question. If I don't know the solution, you get more honey. Ja.
Auf jeden Fall auch Dank von unserer Seite für deinen interessanten Vortrag. Ich glaube nicht, dass es noch Fragen haben, oder? Willst du noch Fragen da? Ich
Möchte noch jemand Honig?
Will noch jemand Honig?
Ja, dann.
Ich habe gestern schon einbekommen, aber ich nehme es gerne.
Dankeschön.
Aber wir haben auch was für dich.
Oh, wunderbar. Vielen Dank.
Kleines leckeres
Drinking.
Dankeschön.
Ja, nice.
So, dann danke für den Vortrag. Ich glaube, wir können noch so ein bisschen zusammenstehen und wenn noch Fragen sind, eine kleine Runde die klären. Danke nochmal fürs Hosting an Trainer. Sehr cool, dass es jetzt schnell geklappt hat.
Nice.
Jo.
Many thanks for listening to this beautiful talk.